I'm Rhianne. Let's talk about bridges. Bridges play an integral role in the transportation system all around the world. Bridges have existed for thousands of years. Origins can be traced back to ancient civilizations in Mesopotamia, Egypt, and India, where they used logs to cross over rivers and streams. From then, there have been advancements such as the masonry arches from China or the Roman arch. There are approximately 1.67 million vehicles that drive daily in the Philippines, meaning if you compute everyone who commutes, carpools, or drive their own cars, it would amount to millions of people who drive on the road or bridges every day in the Philippines alone. It is important that we maintain safety in infrastructures, especially when it comes to bridges. With the large population on the road, ensuring that bridges can sustain large loads, along with other environmental and societal factors, can help save lives and prevent disruptions in our society. It is important that we know which types of bridges to use and when to build them, or simply drive on them. And that is where our investigation comes in. First, I wanted to test my hypothesis, which was if a beam, arch, and truss bridge are tested under constant increasing weight, then the truss bridge will be able to withstand a greater load because its simple and effective design allows for rigidness through the triangular framework, unlike the other bridges. Using illustration boards, cutters, and glues, I made scaled-down versions of the bridges, beam, arch, and truss. I ensured using the same materials with the same measurements, such as the span, to ensure that our only variable is the type of bridge. Then using two supports with height 12 cm, I propped the bridges on the supports and used 1 piece of coins as my loads, which weighs roughly 6 grams. I made sure to attach a string on the supports to have a basis of comparison for the bridges bending. Then when it came for the test, I placed 1 piece of coin one by one and measured the bending using a ruler. And I waited until each bridge fell. Now let us discuss the results that we have. Over here are the table and graph of the results of the experiment. Let us break it down one by one, starting with the beam bridge. The beam bridge was only able to carry 33 coins or 198 grams of load, which can be explained due to the fact that the bridge experiences compression forces at the top of the beam and tension forces at the bottom. However, as more and more of the load pushes down on the beam, it does not dissipate it elsewhere, causing its huge bend and early failure. Next up is our arch bridge. The arch bridge was our second best, being able to carry 107 coins or 642 grams of load. Due to the arch, which was supported by vertical lengths, the bridge did not bend drastically, being able to gradually stabilize and sustain it. This can be explained through the arching shape, which carries the load along the curve and dissipates this to the sides or abutments, hence allowing for more load to be placed on it. Last but not the least, the truss bridge was able to carry the most loads of 130 coins or 780 grams. It was also the most consistent and least in terms of bending, only reaching 3 centimeters unlike the other two bridges which had 6 centimeters. The bridge remained stiff throughout the entire experiment until it simply dropped. This can be explained through the triangular framework wherein the horizontal, vertical, and diagonal members distribute both the compression and tension forces, allowing for rigidness and stiffness in the bridge. Thus, we can conclude that our hypothesis is correct. The truss bridge was indeed able to withstand the greatest load due to its design and triangular framework allowing for rigidness. However, we must take into account that results may vary depending on environmental conditions, where the bridge is located, what its intended purpose is, and etc. Moreover, there are still other different types of bridges such as suspension and cable-stayed bridges, as well as combinations of the three previously discussed bridges, which maximizes the benefits of them all. Therefore, knowing this, we now know how each bridge works and each of its benefits and disadvantages. It's important for us to be well aware of this regardless if we are aspiring engineers or architects or would simply like to understand the intricacies of things in our community. It is important for us to appreciate everything we learn and not take them for granted. What we may find mundane in the classroom may have an integral part in bridging our communities and helping us progress further. And now, you know how bridges work. Thank you for talking with me. Bye-bye!